Right, hello everyone, and welcome to week 6 of ExCode. Considering we had a break from last week. Okay, today's session will be a bit shorter than usual because probably people are wanting to spend the last 2 days of freedom doing other things. I don't know, going to Chev, getting some 99p pints, but you know, alas, we've got ExCode every Tuesday at 6:45, so I won't take too much of your time. Share my screen. Okay. So from last week, we looked at dictionaries, and we also, unfortunately, looked at bubble sorts. You can probably just forget about bubble sort entirely. I shouldn't really have included it. It's quite complicated and ultimately not actually used in many places. So don't worry about that. You can completely forget about it, but don't forget about dictionaries because they're quite useful. Okay, so we'll probably start with a recap of what dictionaries are quickly, and then we'll go into functions, which is the only real thing we'll be looking at today because they're quite useful. So we should go into in depth with them, and then we'll just do some building your own programs, etc. Okay, let's get started. So a dictionary is basically just like a list. It's like a list, but it's also like a real life dictionary where you have a key and then a value attached to that key, and you can search for the values via the key. That's what it's called. So we start this off by just calling it something the same. Let's do so this dictionary. The naming convention is exactly the same with a variable. It just has to be one word, and you can use underscores. So you start with curly brackets and you put down the key. So in this case, we'll just do people's heights. I'll just random name and then colon and then the value. So let's say if Sam's 178 centimeters, we'll give them that. And then you put a comma, and that means you want to put another value in the list. So I could do, let's just do James. James as a string, and then the value attached to that, just do 185, and then maybe do Nicole, and then put 168. So basically, it's just using curly brackets, and then you're using the value you want for the key, and then a colon, and then the value associated with that key. You can add as many as you like, and it's really efficient to search through. And it's pretty useful. You can sort of just add things to a dictionary by creating a new key. So you do this dictionary and then square brackets, and then whatever you want to call it. So if we do another one, we just do Rob, and then we do equals 180. And then when we print out this dictionary, you'll see that it should be added onto the end of the dictionary. So it's much like using a list where you access everything by its key, whereas in a list you'd use an index where they're ultimately just the same thing. You can assign variables, the values that are in dictionaries. So if we have a variable called x and we just assign it Sam, and then we print x out. Oh, spelled it wrong. It should assign the value that's associated with the Sam to the variable. You can delete something from a list by just doing delete and then doing this dictionary, name of the dictionary, and then the name. So I run this and then print out this dictionary. You can see it's removed Sam from the list because I've deleted it. You can also loop through dictionaries like you loop through a list, or slightly different. So if I do for x in this dictionary and I just do print out x, let's put this dictionary wrong again. Butterfingers, right? Yeah, as you see, it's when I do this, it's for x in this dictionary. It will x, like a for loop, is replaced by all the keys in the list, in the dictionary, sorry, and you can just print them out, do whatever you like with them. yeah, and you can also loop through the values of a dictionary. You can just do for y in this dictionary and then dot values, and then just print out y, and it should print out all the associated. Do I just keep, it has no attribute values. I'm really misspelling everything today. Dot values, and then it should just print out all the values that are associated with it. And if you want to get both the key and the values, you can use dot items. So if I do for x, y in this dictionary, and then do dot items, and then I can just do print x and y. And if I do that, I'll just get rid of these so it's easier to see. I can get x will be represented by the names, and then y will represent the heights. So it's just the key value, just pair. You can get them. Yeah, that's probably everything I believe from a dictionary. I probably won't use them today much, but just good to go over them anyway. Okay, so functions. A function is basically a named block of computer code that runs when you call it. So for instance, if you, I don't know, if your computer program's not running properly and you have like an error message, and every time an error comes up, you want to print the words error found onto your screen. And then once the error is found, you want to do something like tell the server to halt or the server to restart or something like that, just anything that you want to do when an error is found. You don't want to have to write this every time there's potentially an error being found. You want to sort of be able to call something that handles it itself. So you just want to, it's basically making like, so you've got really important code and you want to use it multiple times, like throughout the program at random points. You don't want to have to completely rewrite it over and over again. So that's sort of where a function comes into play. It's basically something that you can call, and then it will tailor program to go there and it will complete that code. So in the case of like print there's an error been found, or for instance, you were given like any sort of code and you wanted to at some point just basically run it, you'd use a function. So for instance, if we had a really like complex mathematical equation, I won't print one, but if you were to print out, I don't know, 56 times 0.567, 56, and you just you didn't want to have to copy and paste that everywhere. You can do something called a function. So I'll just write that. So we define function. We'll do it. Complicated algorithm. Obviously, this isn't exactly a complicated algorithm doing just multiplication and stuff, but I'll quickly explain what this does. So we define an algorithm, a function, by define and then brackets and brackets, and we can run it. So I'll just do. So what this basically does is we write a piece of code inside this function. So anything that's indented below this function is repeated whenever we call it. So this is a function. And let's just do this again. So every time I call complicated algorithm, it runs everything inside it. So much like how if you do a for loop, you indent things and everything that's indented is repeated every time you run the for loop. This is sort of like that, but a little bit more complex. So if I were to do complicated algorithm, again, it would run everything inside the function. So this simply is just packaging code into like this into sort of like little block, and whenever we want to reuse it, we just call that package, and it will run whatever is in there. So obviously this is a bit simple of like of a function. I'm just printing out things. I'm just saying call this, and whenever I call this, I want you to print all these things out. But you can do more complex things with it. So you could you can put, as I said, like complicated algorithms in it. You can just send it loads of data, different kinds of data, and it'll work on it. But ultimately, all it does is just package code, and when you want to reuse it, you just call it. So the syntax for it is the word def, which just means define, and then the function name. So it's the same sort of naming convention as a variable, so or a list or a dictionary, where you just, it's one word and you can use sort of underscores to represent spaces. So I'll just do another simple one, which is print words. And then it's followed by two brackets, so I can open and close bracket, and then followed by a colon. And then everything that you want to be repeated when you call that function must be indented below it. So that's like, it will automatically do it, but if not, you can just click tab and it will indent it. And then from there, you just put whatever code you want in there. So hello Exeter. And then every time you run it, it will, even whenever you call this function, it will run whatever's below it. So yeah, and if you want to call it, you just do the name of the function. So in this way, it's just print words, followed by close and open bracket. And then when you do that, it's called calling a function. You've just called the function, said do your thing, and it's basically just does whatever's indented. So this is nice and all if you want to like repeat really simple stuff, but a lot of the time when you repeat, want to use functions, you want to actually send something to the function, like something specific, like values you have, and then sometimes you also want it to send things back. So first we'll look at passing things into a function, and then we'll look into functions returning things. So for instance, let's say you have, you're working with trying to like find the average of something. So let's say I have a list of values like, let's say, so just do value 1 and just give it 987, and then let's do value 2 and give it the value 789, and then just do, yeah, so let's just do 2. So imagine that like 100 times in a program, I will come across 2 values that I need to find like the average of. I don't want to have to find the average of those. I don't have to write the code to find the average 100 times. I'd rather just send those 2 values 100 times, like 100 pairs of values to a function, as opposed to writing code to every single time I want to find the average of them. So if I want to make it, I could make a function called, what I define as find average. And then I would love to send them these values every time I want to. So for instance, I only want to send it 2 values here. And I'm going to give them the names of, so I'll just give it X and Y, just simple values. So up here, we didn't include anything inside these closed brackets when we're defining a function. But when we put it here, what we're saying is we're expecting, when you call this function, we're expecting you to send us 2 values. So we want to, this function won't run unless we send it 2 values when we call it. And when we send it 2 values, we can sort of manipulate those values. So in this case, we're going to send it those 2 values, and then we want it to do something, in this case, find the average. So what basically happens is if I were to call this function, so I'll just do a function call like this before, we just do the name and then you use 2 close brackets. But this time we want, instead of like leaving these 2 things empty, we want to fill them up with values. So in this case, we'll do value 1. We want to send it value 1, and we want to send it value 2. So there we go. So basically we're calling it and we're sending it value 1 and value 2. And if we go up here to the function, we'll see we've got X and Y. So X and Y are basically replaced by what's inside value 1 and value 2. So ultimately what's happening here is I call the function and I send it 987, and that's what X is, and I send it 789, and that's what Y is. So now, if I print out X, you put that down there because I haven't actually created the values yet. And if I do print X and then I do print y, you should see that if we run it, it's printing out 987 and 789, because when I call that, it's replacing x with that value, which is here, and then it's also replacing y with this value, which is here. So you're basically just sending it values, and it's basically setting a temporary variable inside it, which represents them, and you can sort of manipulate them from there. So I could just, as I said, would do the average. I could do, so total sum equals x plus y, and then I could print out total sum, and it will come out with the total sum of that plus that. And then obviously I said I wanted to find the average, so I could do average equals total sum divided by 2, and then just print out average. So that's 888. So we can do this with any sort of value, however many times we want. So I'll do value 3, and we'll set that to 89, and we'll do value 4, and we'll set that to 560. And we can just do find average, and then just send it value 3, and we can send it value 4. When we run it, it will this time use what's here for x, and then what's here for y. So we can just call this however many times we want with different values, as long as there's the same amount of values inside the call as there are in the actual function, it will run and it will work on them. And so this is just a good way of not repeating code and just making things specific to the values that you want to use. Okay. Now, probably something to note is when you send these values into the function, you're not manipulating the value that's outside the function. So basically, when I send it value 1, it basically copies the value that's inside value 1 and assigns it to x, and it copies the value that's inside value 2 and copies it to y, so that you're not actually manipulating the variable. You're just basically just copying and pasting what's inside the variable and transferring it. So anything you do in here to the things you've sent do not affect anything outside. Okay, so another thing I said, you can return values from functions. So here we've sent values and we've manipulated them. So you can also send values there, and then you can return values back. So so for instance, let's say you had, let's just use z equals 56.4. Actually, let's just do simple. Let's just do 3, and then let's do w equals just 4. And let's say we wanted, there's multiple times in a program where we want to find like basically just 3 times 4 times 4, for instance. So we wanted to find just z times w twice, and you don't want to have to complete writing out the code. This is obviously a really simple example, but and we want to assign what's done inside here. So for instance, in this case, we found the average. Let's say we don't just want to print out the average, we want to return the average. So we want to store the average in a variable outside the function. We can do that by sort of returning it. So let's just do define a function, and we'll do multiply. It's just called the multiply value, and we'll send it z and w, but we'll call them x and y inside here. So let's just call a variable, let's call it multiplied value, and it's equal to z times w times w. Let me print that out. That should, if we print that out, it should be sorry. Sorry, I'm just making so many mistakes. Okay, multiply value. Oh, Jesus, multiply value. Okay, there we go. So in this case, we've done what we've just done before, where we've just taken values and printed onto a screen. But let's say we want to have a value called O, and we want O to hold the result of what's done in here. We can return multiplied value. So we can use the word return multiplied value. And we can assign it here. So if we do, so we've got rid of print, so it's not showing up. But what's happened here is we're basically we're sending Z and W to this, and then it's multiplying Z and W. So it's doing in this case Z times W, and it's applying it to multiplied value. And then we're returning multiplied value. So what this is basically is it's doing this, what's all above here, and then it's sending it back to what's called it. So when we do 0, or let's just call it a better one, so it's final value equals multiplied value. What we're doing is we're assigning, so obviously like a variable, you assign everything that's to the right of the equal sign is applied to the left. So we're saying the variable final value is assigned what's returned from this function. So if I were to print final value, it should be 48. So what's happened here is I've basically multiplied x by y and then by y again, and I've assigned it to this variable. And then the function is then returning it, and when it returns it, it's applying it to this variable outside the function. So I'm basically doing the calculations inside the function, and then I'm sending it back to be assigned. So I can I'll just do another one. So I could do second value, second final value. And I could do multiply value again, and I could do multiply value to 5, and then what should happen is it should go, okay, we want to assign something to this variable, and we want to assign the result of this. So we go up to multiply value, and we've input 2 and 5. So it will then do 2 times 5 times 5. And then it will return 2 times 5 times 5 because it will return this variable. So now if I print out second final value, it should come back as 50 because 2 times 5 times 5 is 50. Returns it, assigns it to second final value, and then prints it out. So you can basically you don't just have to do things inside the function and leave them there. You can do things inside there, manipulate things, and then send back certain things. This can be like what we've done here. We've just sent back the result of some multiplication or algorithm, or it can be like true or false or strings or anything. You can basically return anything. But honestly, we just want to just do anything that's useful, and that we don't have to keep repeating code. We just want to save ourselves some time and make things a lot easier for ourselves. Now, so in the above one, we've sent only 2 variables. You can send 3, you could send 4, you could send 5, you could send, honestly, you can just send as many as you like. But sometimes you don't know how many variables you're going to send to a function to act upon. So there's a way of doing this called args, where you basically just say, okay, we're expecting a number of variables. We don't know how many, but we know we're going to be sending some. So if we just start off by creating a usual function, so let's just do sum values, and then obviously we do the two brackets, and then inside there we'd usually put what we want, the arguments, what we'd want to call the values we've sent to it. But in this case we don't know how many, so we do an asterisk, and then we do any name, like any variable name. So in this case I'll just do values, then finish off with colon, and then go down. What this is basically saying is we are sending you variables, but we don't know how many. So store it in values as sort of like a list. So if I'm just going to print values, I'm going to send it. So if I do, I'll just call the function, and I'll say, let's just do 12, 34, 56, and 76. So now I call it with 12, 34, 56, 76, and then I print out those values inside the function. As you can see, it comes out as 12, 34, 56, 76. So I've sent it all those values. I could just change that to like 76 again, and then 43. If I run it again, it will have all of them. So I've sent it basically what's basically a list, but it's actually called a tuple, but a tuple is basically a list, but you can't change the values. So just treat it as basically a list that you've sent it. Just know that you can't change any of the values. So you can use as a list. So for instance, we have the values. I could do for I in some values. So I'll iterate through, use a for loop to iterate through every single value in, in values. And then I could do the exact same thing again, but print them. So I could just do print I, and it'll print them all out again. But in this case, we want to, as I said, it's just some values. So we want to sum them together. So actually, I should note that it obviously, as I said, it's like a list. So if you want to get like individual values out of it, you can just do like give it its index, and it will come out as its index. I could just give it the first value, and it will come out as 12. So it's basically just a list. But in this case, we want to add them together. So we could do total equals 0, and then do for I in range. For I in values, and then just do total equals total plus I. So we're just looping through everything that we've sent it, and we're just adding them into the total. And then we could return total once we've looped through all of them, and we could do print some values. So I'm just basically, you're just sending it. You're not saying how many you're going to send, how many variables you're going to send it. You're just saying we're going to send you some, and then you can treat it as a list, and you can do whatever you like on it. As you can see, you can use for loops inside functions. You can use ifs, whiles. You can basically just do anything you like in a function. But just remember to indent it, because then it treats it like its own little block, which is repeated. Yeah. So hashtag, and then not a hashtag, asterisk, and then we want to call the basically the tuple or the list, and then just go through to what you want. Yeah, so that should be everything for functions, and I believe that's everything for today. So functions are basically just pieces of reusable code that can be called and can return values to and from, the programmer. So a lot of the time you'll have lots of code that you'll want to reuse, and this just saves you from having to rewrite it every single time. But it's also something you have to note is when you try to call a function, so in this case I want to call some values. If I try to call some values up here, oh, that doesn't work, that's fine, don't worry. Don't worry. Yes, so that's about everything. You just have to define your functions and then call them, and then blah blah blah. That should probably be it. You should probably split off into your workshop groups, and that should be it. So thank you very much, everyone. And I realize it's only been half an hour, which is probably actually the goal. Thank you very much. Hopefully you've learned something, and there should be a few extra questions at the end of this one, since we didn't do one last week. Okay, take care, everyone. Thank you.
I was wondering if I can ask you a quick question before I go to the smaller rooms.
Yeah, that's fine.
So I picked up like a 5-second call at the very end, so I kind of missed it a little bit. So I didn't quite catch the last part about the for I in value and total equals total plus I part.
Okay, yeah. So so this part is, do you get that you're sending it, you don't know how many things you're sending the function?
I mean, I don't know how it works.
So this part here. Sorry, let me just share my screen. Sorry. Yeah. Okay, so you're talking about the this part for I in values?
Yes.
Okay, so let me just do that. So let me just print out values quickly. So that's not working for some reason. That's weird. 1 second. Yeah. So basically, what's happening here is let me just go back to when I actually had it working. There we go. Okay. Okay. So basically, when I send it values, you're sending it like a list. So lots of like lots of individual values. So you'll do, if I print values up here, you've sent it 12, 34, 56, 76, 76, 43. When we do for I in values, what we mean is for every single value inside values, do the following. So yeah, so it's saying for 12, do total equals total plus 12. For 34, do total equals total plus 34. And then so on, so on. So you're just going through every single value in the list and adding it to total. So anything that's indented inside is done with it. So every time you complete this sort of, this list, I, which is here for I in, I is replaced with the next value inside, inside values.
Yeah.
Yeah, and then you're basically just adding 12 to total, then you're adding 34 to total, then 56, then 76, then 76, and 43. And then once you've done that for the whole thing, it continues the program, and then it returns what you've just done.
Yeah.
Does that make sense?
Actually, I don't quite understand the whole return.
Okay, right.
Part at the very end.
Okay, so let's think about how to explain this. So you know how you'd assign a variable? So variable like 1 equals 20, 45. What you're simply doing is you're assigning 45 to the variable, right?
Yeah.
Yeah. What this is basically doing is, so in the essence, it's whatever's to the right of the equal sign is assigned to the left of the equal sign. In this case, what's happening is when I do, let me just copy and paste that. When I do variable 1 equals, you're assigning this, what the result of this, to the variable. So I'm calling this function, and I'm expecting it to like give me something back. So what it's done is it's inside the function, it's made total equals, it's added them all together. So it's added everything that I've sent, and then it's returned everything that what I've added together. So I give it this list, it adds the whole list together in total, and then it returns total. So ultimately what this is doing is it's adding them all up, which results in 297, right? So if I add all them together, it gives me the value 297. What I'm simply doing is doing variable 1 equals 297. So whatever is returned here is sent back here. So you're basically, I'm trying to think how else I can word it that I haven't already. You're basically doing an operation and then sending it the result of it back, in a sense.
So you're pushing the result after 43?
Yeah. So I've added them. So I've added all the numbers together, and then once I've added them all together, I'm then returning what I've added together, and then it sends it all the way back here where I've called it. So I'm basically replacing that with total.
Oh, so like you delete the whole 12 to 43 and then you just put the total there.
In a sense, yes. Yeah.
Oh yeah, thank you.
Okay. If you have any questions, just ask, I guess.
Oh yeah, thank you.
I've really got to get to my my group.
Yes, of course. Thank you so much.
No problem.